When comparing human brain with silicon computer, people usually think that computer and brain are two differently working things. In this video, I want to present a proof that human brain does possess direct information addressing capabilities similar to address bus available in computers. I also propose in this video that addressing hardware responsible for this feature is most probably located in so-called cortical columns that are part of the brain we call neocortex. Let's make an example. You are sitting in a room and suddenly you look out of window. Outside there is sun shining. From this moment on, you know that there is sun shining outside of window. This information is now present in your brain. In only fraction of a second, it is stored in your memory. When we translate this situation to processes running inside brain, it is clear that your brain has to make connection among three things: a window, outside environment, and the sun. For simplicity, let us suppose that every one of these three objects is being represented by one neuron. All three objects are already known. That means that your brain has to connect three existing neurons. Because the duration of this process is only a fraction of a second, it is impossible for a human brain to make such connection on physical layer. Connecting neurons physically in a fraction of a second is simply impossible. This means that such a physical connection must already exist in the brain, and what is being created in brain in fraction of a second is only activation of this connection. In other words, the actual connection among three example objects is done on virtual non-physical layer. When you take into account that connecting objects are perfectly random, it means that you need to be able to connect any possible information that is available, and then it is clear that you need some sort of addressing system to achieve this goal. Without information addressing capability, it would be impossible to make such a virtual connection among random objects. This example proves that the human brain has information addressing capabilities. No one really knows how this addressing hardware is working and how it is being wired together in the brain, not even me. But as we know that information is being stored in the part of brain that we call neocortex, and special anatomical feature of neocortex is so-called cortical column, it must be proposed that it is exactly this cortical column that plays crucial role in direct information addressing taking place inside human brain. Please note that the cortical column is about the only hardware structure visible in neocortex, so it will have many other functions as well, including storing memory. Conclusion. This example clearly shows that information addressing present in human brain is similar process to working of an address bus in a computer. It also derails traditional view of information in human brain being connected strictly by physically joining neurons. Please note that I am not proposing a human brain having address numbers being sent through the bus as it happens inside silicon computer. Brain's addressing capability requires all stored information being connected together in advance without actually being activated. What is happening in this fraction of a second is only virtual activation of already present physical connection. cortical column must play a crucial role in this process. This also explains why there are so many connections in human brain and neocortex. When we want to speculate about how such brain hardware works in detail, we must assume that virtual connection is being activated only for information that was simultaneously activated, or as I say in this video, for information that simultaneously entered brain in only a fraction of a second. This is what we call a short-term memory. Exact molecular and cellular mechanism of such virtual connection for short-term memory remains unknown, but it is of no big importance to humanity, as it only shows how part of the brain is working at the hardware level. The software level, the actual brain algorithms that make brain a computing system, are long known. I have developed brain algorithms already before the year 2016.